Welcome back to this video series on the topic of expansion and empowerment. Chapter B, double brackets. In this lesson, you'll learn how to expand expressions containing double brackets. Double brackets are a way of representing the multiplication of two expressions. Consider we have expression 1, a plus b, and the second expression, c plus d. What this means is that we're multiplying these two expressions together. Now, double brackets may be expanded using the FOIL method, first outer, then inner last. What does this look like? Well, it looks like first outer, we get our outer term in the first expression and multiply it with the terms in our second expression. So the a multiplies with the c and the d, and the b multiplies with the c and the d as well. Now, this can be expanded using the intermediate step, where it's going to be a multiplied with c plus d plus b multiplied with c plus d. So what we're able to do is we're able to distill this down into a problem of expanding single brackets. And once we get it to that stage, we simply know it's going to be ac plus a d plus b c plus b d, where in practice we typically go from this form over here directly down into this form over here, and when you become more proficient you can go even further than that, but we won't go there now. Now let's have a look at how we can put this theory into practice. Example 1, expanding double brackets. For the first example A, we have x plus 3 multiplied with x plus 5. The way in which we're going to expand this out is using the FOIL method. FOIL method being, we first start off with going first outer, so the x with the x and the x with the 5. X to the x plus x to the 5. Now we do the inner last, so 3 to the x, 3 to the 5. So we're going to go plus 3 to the x plus 3 to the 5. So this is first outer, and this is the inner last. Okay. Next step down, we do the actual multiplication, so x times x is x squared, plus x times 5 is 5x, plus 3 times x is 3x, plus 3 5s are 15. Next step, what we need to do is we need to do something called collect like terms. So you would have heard your year 8 and your year 9 teachers say this all the time. Collect like terms being the process of when we find terms that have the same combination of variables, we add the coefficients together, or the numbers in front of the variables. So x squared is its own variety. 5x and 3x have the exact same combination of variables, so that coefficients may be added, so 5 plus 3, and the 15 is its own variety as well, it's a constant. So we go x squared. Next we add the coefficients of 5x and 3x, so that's 5 plus 3, which is 8x plus 15. Thus arriving at our final result, or our most expanded form of x plus 3 times x plus 5. So this was achieved by using the FOIL method, first outer, then inner last, then collecting the like terms, and thus arriving at the final result. Alright, let's have another go. Something that looks like it's not what we're working on, but it actually is. X plus 3 all to the power of 2. Now what this power of 2 means is that we're dealing with an expression that's been doubled up. So x plus 3 multiplied by x plus 3. So there's 2 copies of it. Now we've got a expanding bracket situation. So I'll use the FOIL method, first outer, inner last. Expanding this out, this is going to become x plus x3 plus 3x plus 3. Next step, do the actual multiplication. Xx is x squared, x3 is 3x, 3 times x is 3x, and 3 3s are 9. Now collect like terms, x squared plus 6x plus 9. So the 3x and the 3x stack to become 6x, thus demonstrating our second example for example 1. So we expand double brackets by using the FOIL method. First outer, then inner. So draw your arrows and just multiply across your arrows. Okay, let's have a look at something a little bit trickier. Example 2, expanding double brackets containing expressions with negatives. So in the last example we just had positives, now we've got negatives. How do we deal with this? Well, just like we did in the previous example. First one, we have x plus 3, x take 2. We're going to expand this out, first outer, so that's going to be x, x, plus x, and then we get the minus 2. The negative, of course, belongs to the 2 here, so minus 2 goes in the brackets. Inner last, 3 goes to the x, 3 goes to the minus 2. So 3 times x plus 3 times minus 2. Next step, we do the actual multiplication. Xx is x squared plus x times minus 2 is minus 2x. Again, I can get rid of that plus or I can leave it. I like leaving it because I put pluses everywhere. Next, 3 times x is 3x. And then 3 times 2 is 6, so plus 6, but 1's negative, so it's minus 6. Final step, we collect our like terms. There's only one x squared variant. However, we do have 2 x variants, so minus 2x plus 3x. That's going to be just 1x or x. Or another way to look at it is 3x take 2x is 1x, which is same as writing x. We don't have to write 1. And then finishing up, we have the minus 6. So in summary for this example, the thing that made it different was it had negatives within the brackets. We simply deal with the negatives by keeping the negatives associated with the number and then using our rules around integer multiplication, so multiplying negative numbers. Okay, next we have x take 5 times x plus 5. Now for this example, what I'm going to do is I'm going to skip this line over here because this is where you need to eventually be working at. So what you can see is that using the FOIL method, we go outer first, and that's going to be go x times x, which is x squared, and then x times 5, which is going to become 5x. Inner last, you've got this minus 5 here, so the minus belongs to the 5. So that's going to become plus minus 5 times x plus 5 5s are 25 and it's negative, so it's minus 25. Next we're going to collect like terms. There's only one x squared. There's 2 x variables. One's 5 and one's minus 5, so they cancel. And then you've just got the minus 25 at the end. So that's the final result here. So eventually what you want to be aiming for is you just skip the step shown over here. So you can go straight from here to there to there. And eventually when you figure out the rules on your own, because there are rules and patterns associated with these, you'll be able to go straight from here down to here. But I'm not going to tell you that. You'll have to figure that one out. Alright, example 3. Expanding double brackets with expressions containing non-unity coefficients. So big word there, non-unity. Non-unity means something that's not 1. So it could be 2, it could be 3, it could be negative 27, it could be x. So it just means not 1. And coefficient means the number in front of the variable. So when we're looking at non-unity coefficients, we're looking at this 2 in front of the x and this 4 in front of the x. So how do we expand this sort of thing? Well, exactly like we've done before. So it's 2x, take 1, multiplied by the expression 4x, take 3. Expanding this out, we use FOIL again. So 2x to the 4x, 2x to the minus 3. That will become 2x to the 4x, and then plus 2x to the minus 3. Then in a last, minus 1 to the 4x, minus 1 to the minus 3. That will become minus 1 to the 4x, plus minus 1 to the minus 3. Cleaning this up, 2 4s are 8, xx is x squared. Next one, 2 3s are 6, 1's negative, so it's negative 6, and there's a single x. Minus 1 times 4 is minus 4, x. And then 1 3s are 3, and 2 negatives makes a positive. Collecting like terms, there's one x squared variable. Minus 6 minus 4, that's minus 10. Because they're both negative and you're adding them, they actually get bigger, so minus 10x plus 3. Thus completing our third example here. So how we deal with expressions containing non-unity coefficients. Alright, final example. Expanding triple brackets. So we've got x minus 2 all squared plus, or x minus 2 all squared times x plus 3. And what we learned before was that this x minus 2 is the same as saying 2 copies of x minus 2. And this is where we arrive at something that is unique, something we haven't seen before. Now the way in which we're going to deal with this is, as you probably guessed, we're going to use FOIL, but we're going to do this in 2 steps. First step, or first thing we're going to do is this x plus 3. We're going to ignore it. Just pretend it doesn't exist for now. We'll still write it, but we just won't do anything with it. Next, what we're going to do is we're going to do FOIL on the first 2 expressions here. So this guy and this guy, this guy and this guy. And I'm going to do it inside square brackets. So this will become x plus x minus 2 plus minus 2 x plus minus 2 minus 2. And then close off the square brackets. And I know I said we were ignoring the x plus 3, but we still write it, we just don't do anything with it. We just keep stringing it along until we're ready to deal with it. Alright, next step, we'll actually do the multiplication. So we're going to get x squared minus 2x plus 4, and then we collect our like terms. So that's going to be x squared minus 4x plus 4. So nothing we haven't done already. And then we've got that x plus 3 we've been conveniently ignoring all this time. Okay, so we're now at a stage where we'll stop ignoring the x plus 3 and we'll deal with it. And the way in which we'll deal with it is first we'll change these square brackets back into parentheses, so the rounded brackets, and we will move it over here to show that we're doing the next step in this expansion. Okay, to expand this out, what you're going to firstly notice is we have 3 terms within the first expression. We haven't done this before, but we can still apply the FOIL method to it. We go first outer, so the first one on the outer is the x squared, and we just do it like we did before, ignoring that there's 3 terms for now. So it's x squared, x squared 3. Next, we're going to go for the inner one, so the minus 4x is going to go to the x and then to the 3. So this will be minus 4x, x minus 4x 3. And here's where it's different. Here's where we finally deal with the third term. So we've got this plus 4. We just go for a third set of arrows. So we're going to get plus 4x plus 4, 3. And what we've been able to do there is to easily overcome this problem of having 3 terms within the first expression. Now all we need to do is do the actual multiplication, then collect like terms. So x squared times x is x cubed, plus x squared times 3 is 3x squared. Take 4x times x is 4x squared. Take 4 times 3, which is 12x, then plus 4x plus 12. Collecting like terms, there's only one cubed term. There are 2 squared terms. 3 take 4, which is minus x squared. Then this guy should be a 4x. Minus 12x plus 4x is going to be minus 8x. Plus, finishing this off, we have 12. Arriving at our expanded form. So the way in which we do this is we just ignore all but 2 of the brackets. So we ignore the third one in this case, and we just work on expanding the first 2 brackets, breaking this down into a singular bracket, and then we expand this outwards by treating each term within the first bracket with a pair of arrows to expand outwards. So rather than having 2 arrows, we have 3 arrows, and we just follow the rules, thus arriving at our final result here. So in summary, what we had a look at in this lesson was how we can expand double brackets. The way in which this is done is we use the FOIL method. So we go first outer, then inner, last.